Hello world, good morning, good afternoon, good evening. Welcome to RoboThought Zero to Hero series. C coding in Arduino Mega, Arduino UNO, Arduino Nano, any of the boards you can use for this particular series of programming to learn C coding. Alright guys, so we are on lesson number 46, Arduino C coding, and I'm going to talk about ultrasonic distance sensor. So this is a standard sensor which is very widely used in most of the robotics projects guys, using Arduino or Raspberry Pi or Jetson Nano or any of the single board computers or microcontrollers. Alright, so this is called HCSR04, which comes along with several bundles. You can place it online. So basically in this lesson I will show and explain about ultrasonic distance sensor, how to configure and how to use C coding to make it to work. All right, so basically the ultrasonic sensor, the HCSR04, is used to measure the distance of the object using sonar, SONAR, sonar. It basically emits the ultrasound at a frequency of 40 kilohertz or 40,000 hertz. Okay, the frequency travels through the air and strikes on a particular object on the path, right? When you're building a bot and you have ultrasonic sensor in the front or in the side or all the directions, it will just hit on the object through this particular frequency. The rays which is bounced back from the object and reach back to the particular module, that is your ultrasonic module, that is this particular module. So basically the ultrasonic sensor works best for medium ranges. Okay, this is not meant for any long range trigger or kind of thing. It is basically works in a pretty much short range. The resolution of this particular sensor is approximately about 0.3 centimeter. The medium range of the sensor are about 10 centimeter to 3 meter approximately. So that's the maximum stuff you can get. So it also works best at this particular duration. The maximum range of the sensor may detect up to 4.5 meter when there is nothing around in your environment. So let me just talk about it a little bit, the way it works. All right, so basically let's look at the drawing above me. So the sensor basically sends a ultrasonic high frequency samples. It just keeps triggering the sample which we cannot hear, humans cannot hear, right? When those sample frequency hits on a particular object, okay, which strikes on an object, it bounces back from that particular object, and the distance sensor, this particular sensor HCSR04, reports the time. It captures the time it takes between sending and receiving, the time it takes to send and receive. What's the time duration of the particular sample triggers? All right, the four terminals which you can see in this drawing of HCSR04 are basically the VCC, which connects to your 5-volt of Arduino, and there is a trig pin and an echo pin and a ground pin. Ground pin goes to ground, and the trig and echo is the one which you communicate with digital or analog, right? Okay, the voltage supply is, of course, it's a 5-volt. You may also use more higher voltage, but you need a stepper or a resistor and regulators and stuff like that, which I'm going to talk about this at a later stage when we get into more advanced stuff. So we can connect the echo and trigger terminal to any of the digital input output pin, okay, on the Arduino UNO board. In Arduino Mega you have more number of pins. In UNO we have pretty much limitations, right? So what do we have here? So basically if you look at the circuit drawing, it's pretty much straightforward. We need to first set the trig pin at high, right? It will send out the burst of 8 cycles called the sonic burst. Okay, so let me go back to the previous drawing. It might it's pretty much self-explanatory. The sonic burst, which will travel at a sound of a speed, it will be further received by the echo pin. So that is how the trig pin and the echo pin, the way it works. The time traveled by the sound wave is considered the echo pin's output time in microseconds. So we will use the pulse in function, which is basically one of the inbuilt functions in Arduino IDE, to read the time from the output of the echo pin. So it will wait for a specified pin to go high and low, that is from 1 to 0 and 0 to 1. That's how the system works. The function would return the timing at the end of the trigger. The trig pin is set low for about 4 to 5 microseconds and then high for about 15 to 20 microseconds. It's microseconds, guys, not seconds. Okay, so timing will be calculated only in microseconds. That's the easiest way to do. So basically, if you look at the circuit drawing, let me just move to the drawing again. So you may want to pause the video and connect your ultrasonic sensor to as per this particular drawing. So it's pretty straightforward. I have used, let me just show you the way I have put it together for this particular tutorial, so that you have a better idea. So I did not use breadboard. I directly connected the ultrasonic sensor with all the 4 pins to the respective output, the digital pins of Arduino, and positive 5 volt and the ground pin. So it's a pretty straightforward and a simple connection, right? So basically, if you carefully look at the drawing, your VCC pin goes to 5 volt and the ground pin goes to ground, and the trig pin goes to pin number 6 of Arduino, and the echo pin is connected to pin number 5. Now the exercise what we are going to do, so that you can understand in a much better way in this particular lesson, is let's take an example. Say there is an object away from your robot, say about 40 centimeter from the ultrasonic sensor. You have a robot. Let me just take some board in my hand, guys, so that you will understand this. Alright, so this is a pretty simple robot, right? And this is the ultrasonic sensor. Say for example, you have a board here and you have about 40 centimeter away, there is an object, right? Either in the front or in the side, about 30-degree diagonal, okay? Any of this position. So the speed of the sound in the air is about 340 milliseconds. So this is a standard calculation. You need to make a note of it. I'm going to talk a bit about the formula, how we are going to calculate, and I'm going to put this formula in the video comment below, right? You can take a look at it and you can save it. So we need to calculate the time in microseconds. So for example, V is equal to 340 milliseconds microseconds equal to 0.034 centimeter divided by microseconds. That's the way it works. So the time is equal to distance divided by speed, and time is say 40 divided by 0.034, because we are calculating 40 centimeter away, and ultimately the time is 1176 microseconds. That is the way output you get. And the speed of sound from the echo pin will double it, because the wave travels forward and backward. It bounces back, it will hit and bounce back, right? So to calculate the distance, we need to divide it by 2. So the distance is equal to time multiplied by speed of sound divided by 2, and the distance is equal to time multiplied by 0.034 divided by 2. So that is the way this calculation works. Do not worry, I am going to leave this formula down below this explanation section of this video. You may take a look at it. Okay guys, now it's time to do some coding, and I'm going to share my IDE. Let's go to my Arduino IDE and do some coding, right? So what we need to do, first we need to define the pins. So let's say hash define, let's define, we have 2 main pins, the echo pin and the trigger pin. Say echo pin. You can name anything you want, guys. So echo pin is connected to pin number 5. So this basically defines the echo pin of the sensor to pin number 5 of Arduino, okay? And then let's say define trigger pin, and the trigger pin is again a variable, so which is connected to pin number 6 as per the circuit drawing. TRIG, you can name it anything you want, trig 6, like this, trig pin 6. And then let's say the long duration, like this, long. As soon as you put long, you can see the happy little color changes in Arduino IDE. It's an inbuilt function, right? And this is basically the variable for duration of sound wave travel, okay? And then int distance, semicolon. So this is the variable for the distance measurement, okay? Now let's go to our one-time setup, that is the void setup function, and I'm closing the function, and we need to open a curly bracket like this. Now inside the function we need to say pin mode, right? The pin mode is your trig pin, comma output. So we are going to, it sets the echo pin as a output, okay? Now let's say pin mode, pin mode, like this, pin mode echo pin, okay, echo pin. Now let's take the echo pin as input. Now this will basically take the input from the echo pin. Now what we need to do, let's do a print, say serial dot begin at the rate of 9600 baud rate. Now this is a serial communication at the rate of 9600 bits per second. So, and then what we need to do, say let's print serial dot print ln. Let's print a line, say double quote, I am testing ultrasonic sensor, and then end with a double quote like this, and a semicolon. So this will basically appear on the serial monitor. You can put anything you want, guys. It's not mandatory that you need to print this line, but you know, I'm just making it a little bit of fun. And then let's also say serial dot print ln, and we will put another line, testing ultrasonic sensor with Arduino UNO board, like this, okay? This is just an option. And now let's come out of this block of code. So how do we come? We need to come out of that curly close bracket and open bracket and the close bracket. We need to come out of that particular block, that is called the block of code. Now we will say void loop. So void loop function, I am setting the function as void loop, and then I'll open another curly bracket. In the curly bracket I am going to do, say let's say digital write, I think, yeah, let's go with, so let's first set the trig pin at low for about 2 microseconds. Say digital write. Now what do we write? Digital write, say, let me just scroll this up. Digital write, okay, digital write trig pin to low. Let's start with 0, that is your low, and then say delay microseconds to say about 4 microseconds approximately. Alright, Now let's say digital, let's go to digital write. Now this, we need to set the trig pins at a high for about 15 seconds. So how do we do that? Digital write and digital write trig pin comma high, like this. Okay, once you set it to high, and then we need to again delay microseconds to say about 15. They will delay this for 15 microseconds, and then we have to write digital write trig pin to low. Say trig pin to low, like this. Okay, now once we have done this, what we need to do is we need to read the echo pin, and this will basically return the values, right? So how do we read? So we need to say duration equals to say, let me just scroll it down a little bit. Duration equals pulse in. So this is an inbuilt function. You can see the color changes in the IDE, so obviously it's an inbuilt function. So pulse in of echo pin, we need to switch it on. So that means it is high if you want to on it. Now let's look at the distance formula, which I explained to you a few seconds back. So we need to apply that formula. So what is the distance? So distance, oops, it should be in a lowercase. Distance equals duration multiplied by 0.034 divided by 2, like this. Okay, semicolon. So this is the speed in microseconds, and then we need to calculate the speed of sound wave, that is your 340 milliseconds divided by 2, that is your forward and backward of bounce. The signal hits and comes back, that is the forward and backwards. So how do we send that? So serial dot print what? Let's print distance. Serial dot print distance, and we will put a colon, space, and a quote, double quote, and as semicolon, and then serial dot print, we need to print distance. Okay, like this. Now let's say serial dot print ln to centimeter, okay, like this, and a semicolon. So this is a specified unit for distance. That is what you are going to print and see the output. Now where is my alright, now we need to come out of this curly bracket. You know what I said before, it's a block of code. So we need to come out of the block of code to make sure that we get in exactly correctly. All the things are set right. There shouldn't be much of a space, and we shouldn't have too many gaps in between. Let's take a look. I hope this runs wide loop, wide setup, and I don't see any. Let me just compile this and see. Let me compile. I hope there are no errors. Oh, pin mode. Okay, there you go. I missed to put a semicolon. There you go, semicolon, and there is one more mistake, semicolon. Now let's see. Done compiling, looks beautiful. Let me upload this. Uploading, there you go, it's uploaded. Now let me open the terminal. You need to go to the right corner, open the serial monitor. There you go, guys. I am able to, let me just share my terminal to you guys. There you go. Can you see the distance? I'm just trying to keep my hand above the ultrasonic sensor. Can you see? It's just hitting my hand and it's measuring the distance and the in centimeter. Perfect. Great. I think this works perfect, guys. Excellent. So I don't see any issue at all with this particular configuration. So guys, this is pretty much a basic setup, right? It's very easy to understand. If you keep this formula in mind, all you need to do is use your logic and understand the C code, the C++ programming, and follow those systematically with the proper syntaxes and the functioning of the sensors. So it's pretty much simple. So guys, what we will do is I'll I'll prepare a couple of more lessons using ultrasonic sensor, and we will also drive a couple of more sensors and motors and stuff like that using Arduino, so that we reach to a point that by the time we finish the series, we will know how to connect this entire project with our Jetson Nano lessons, and we will start building, the ROS. We will start installing ROS on Jetson Nano, and we will start using the ROS serial to communicate with Arduino to drive motors and sensors and stuff like that. So that is going to get more interesting, guys. All right, so do give me a thumbs up and a like, and I'm going to get back to you soon in the next video. Do stay tuned. Bye bye.